Oh, no. In number 3, what's different? Joe.
Y squared.
Y squared. I like that. What else? Tristan.
Everything's on one side.
Everything is on one side. Ivy. Same thing? Mason.
No parentheses.
No parentheses. We don't have it in standard form. So there are a lot of things actually that are different. When this occurs, what you are going to do is you're going to look for the squared thing. Which thing is squared?
Y.
The y thing. I'm going to take that and I'm going to put all the y junk on one side. That means I'm going to go with 2y squared minus 4y, and I'm going to leave that on the left side because we learned that in the standard form of a parabola, our squared crap is on the left. Everything else, I'm going to move to the right. So I move all the other stuff. The negative x becomes positive x on the right. The positive 5 becomes negative 5 on the right. And then we're going to complete the square. Remember that stuff? Yay. What that means is when you're completing the square, you're going to turn the stuff that you see on the left into a perfect square. To that end, I'm going to factor out a 2. So I factor out the 2. I'm left with y squared minus 2y. On the right, I still have that x minus 5 stuff. Maybe I shouldn't have put a parentheses, huh? Let me erase that for right now. Just write it as x minus 5. Now, as I look at that stuff, and I try to complete the square, in order to complete the square, I look at the non-squared term in the parentheses, and I see a negative 2. In order to complete the square, you take half of negative 2, which is negative 1, and you square it, which gives you positive 1. But that blue number has just unbalanced our equation. You're not allowed to just add numbers in. So in order to balance it, you do the same thing to the other side. So since I added 1 to the left, I'm going to
Subtract.
add 2 to the right. Good try. Balancing, you know, like lifting weights. So, oh, wait. Why is it a plus 2? Because the 2 is being distributed to the 1. So you didn't add 1 to the left. You added 2. So in order to balance it, you add 2 to the right. After I've completed the square, the whole goal is to put this in what we call standard form. And so once I've done that, I can now rewrite my stuff in the following way. 2 times parentheses y minus 1 squared equals x minus 3. And so what you see is a squared parentheses, and that's because I look at the first thing in the pink parentheses, y squared, take the square root, that's my y. I look at the last thing in the pink parentheses, that's a positive 1, take the square root, that's the 1. And then I look inside that pink parentheses and I go, hey, do I see any negatives in there? And the answer is yes, so I put a negative sign in between them. If there was no negative inside that parentheses, I put a plus. After I've done this, I notice that there is a 2 in front of that. Not good. So I put a parentheses around the x stuff, and I go, oh, I don't want that 2. So how do I get rid of the 2? I can divide by 2 or multiply by a half. So I multiply each side by a half, and I end up with y minus 1 squared equals 1/2 parentheses x minus 3. And now I'm in the situation where we were in the first 2 problems where I have a parabola in its standard format. This time, however, we have y squared. So instead of my parabola opening up and down, it'll open right or left. The number in front of the non-squared parentheses is positive. That means I'm going to open to the right, because that's where the positive numbers are, to the right of the origin. So I'm going to put a little note to myself. I know that this parabola should be opening to the right, so I don't make a mistake later. As I create my coordinate axes system, the most important thing to write down is my vertex. In this case, my vertex is going to be 3, 1, because remember, the x always comes first, even though it was on the right-hand side. So I put that down, 1, 2, 3, 1 as my vertex. And I know that I'm going to be opening up to the right. After I find my vertex, I always like to find my axis of symmetry. The axis of symmetry is the line that folds the parabola in half. Remember, it always goes through the vertex. Oh, look, it's a horizontal line. That means I will have a y equals something. And since it goes through the vertex, it has to be y equals 1. Because 1 is the y value of the vertex. So that's always nice. Nice clue to have. After we find our vertex and our axis of symmetry, it's important to find the p value. So I look in front of my non-squared parentheses, and I see that I have a 1/2. And I know that my 1/2 is the same as 4p, in case you don't remember. So 1/2 is equal to 4 times p. In order to figure out what the p is, I would divide both sides by 4 or multiply by 1/4, which means that my p actually has to be 1/8. Since the p is 1/8, that means from my vertex I'll be moving 1/8 inside the parabola and outside the parabola. The focus is a coordinate and the directrix is an equation. If I move 1/8 of a unit inside my parabola, my focus that's in there is going to be 1/8 unit to the right of my vertex. That means that my focus is going to be located at 3 1/8, comma 1. As I look for my directrix, I know that my directrix is going to be 1/8 of a unit outside my parabola, which means it's over here somewhere. Notice how it's a vertical line. That means that my directrix has to be an x equals something. And I need to go 1/8 of a unit to the left from my vertex. So my vertex was at 3, 1. So now my directrix would have to be at x equals 2 7/8. In number 4, same situation, a y squared, which means we're going to have a sideways parabola. We have to complete the square. We're going to put the y stuff together first. So I have y squared minus 6y on the left-hand side. Everything else goes on the right-hand side. So that would be a 4x when I switch sides, minus 17. I don't really have to factor out anything because there's no coefficient in front of the y squared other than a 1. So that's kind of nice. In order to complete the square, I take half of the negative 6, which is negative 3, and I square it, which is positive 9. Since I added 9 to the left, I'm going to add 9 to the right. When I rewrite this, on the left-hand side, I will have y minus 3 squared. I took the square root of the y squared and got y, took the square root of the 9 and got 3. Notice that there was a minus sign involved, so I put a minus in the middle. On the right-hand side, I see that I have 4x minus 8. But that's not really in the way that I want to see this, because there's usually a parentheses there. So I'm just going to rewrite that one more time. I'm going to rewrite it as parentheses y minus 3 squared equals 4 times parentheses x minus 2. And now this is in the format that I'm used to. I notice that I have a y squared thing, which means it's sideways opening. I notice that the 4 is positive on the right-hand side, on the non-squared side, which means I'm opening to the right, just like the previous one. I draw my coordinate axes, and I have to find my vertex first. So I find my vertex by looking at what makes my parentheses 0. What makes the x parentheses 0 is a 2. What makes the y parentheses 0 is a 3. That means that my vertex is at 2, 3. And I know that I'm opening to the right. Next, I like to find my axis of symmetry. So my axis of symmetry must go through my vertex. It's what you have when you fold the parabola in half. And so this is a horizontal line. That means I'll have a y equals, and all I have to do is look up into the vertex and write down the y number, which is a 3. And that's my axis of symmetry. After I find my vertex and my axis of symmetry, the next thing that I do is I find my p-value. I know that I always have 4p because it's in the formula, and it's always equal to the number that's in front of the non-squared parentheses. So in this case, 4p is 4. If I solve that equation, I find out that my p is 1. That means that I will travel 1 unit inside and 1 unit outside to find my focus and my directrix. Going to the inside to find my focus, I go 1 unit inside of my parabola from my vertex. My vertex was at 2, 3. That means I have to go to the right 1 unit. So now my focus is at 3, 3. Here's my focus at 3, 3. To find my directrix, I have to go 1 unit backwards and draw a line. So I go 1 unit backwards and I draw a line. And when I go 1 unit backwards and draw a line, I see a vertical line. And for my directrix, that means that my line is going to be an x equals line. And 1 unit backwards from my vertex will be x equals 1. Questions? Okay, last one of this type.